Now first we'll discuss the few point about the torque developed. That is the first point you can write down here. Torque developed. Now give the heading that torque developed denoted as a TT. Okay, this torque is the developed torque, and this is the torque used to produce electrical energy to mechanical energy. Okay. Energy. Understand? This is the torque developed that is required to produce or convert electrical energy to mechanical energy. Understand my point? Okay. And this is, you can say another name, that is your useful torque. Okay. Now, what is the formula of torque developed? Torque developed formula is equal to mechanical power developed in induction motor divided by angular rotor speed. Okay, and it can be further denoted as a TD. Mechanical power developed in motor, that is your PMD, you can write mechanical power developed divided by angular rotor speed. Okay, and this is your TD equal to this one, right? Clear? And this may be further derived, we will calculate the mechanical power developed PMD equal to TD into omega r. Okay, this is the first equation you can remember. Okay, next or next slide. Now next point will come, that is your, you can write here starter power. Okay, or we can say that is, sorry, that is starter power, or you can say air gap power, or you can say rotor input power. Okay, my point is getting, and it is denoted as PG. Okay, now the point is see that PG, how to calculate, and PG. What is the meaning of PG? That the power is transferred from stator to rotor. PG is nothing but the power transferred from stator to rotor. Then PG, the formula is d omega into PV. Then denote another name, that is equation number 2. What is your omega is? That is starter angular speed, right? And dt is, that is equal to developed. Okay. Now see if we are even giving a heading of this one that um, power. One second. It is the can write here. Yeah, basic one is your PMD. Already in the previously we discussed. Another one is your PG. This is two powers already we discussed. Now we are from the developed torque to we are entering to the power mechanical power developed and the air gap power developed. These two we are discussing now. If we are discussing these two power equation one and equation two, one equation is a common we already derived that one. Now we are finding out the losses because we know you see there is a air gap power variable. Now Pg equal to omega s into Td. One, suppose this is your equation two already we discussed. Now, then another equation we discussed that is your PMD, that is your omega r into Td, right? This is your equation one. Now the point is this is mechanical power and this is your air gap power. Then now next point we discussed one point that is losses because this is output. You can say this is output, this is your input. Okay. Then what is the losses? You can put here the losses or you can write here that is losses means that is your copper loss power denoted is P copper. Okay. What is that? That is nothing but input power Pg minus okay, Pmd, right? Now if we will put this is equation number 3, then what we can do? Put equation 1 and equation 2 in equation 3. What we will get that P copper that is equal to Pg minus Pmd. We put the values that is your omega is into Td minus omega r into Dt. If I will take common, Td is equal to omega is minus omega r, or we know that another form that omega s is equal to angular speed. Then what is that? We can write here 2 pi ns. Okay, and already we discussed that ns is nothing but capital Ns by 60, right? Similarly, omega r equal to 2 pi nr, and here also nr equal to capital Nr by 60. Ns means in rp is revolution per second. Similarly, we put here that is your we can put here omega this formula again that is p copper that is equal to uh, dd into omega s minus omega r, right? Then if we are take put 2 pi n s that you can take 2 pi dd then ns minus nr, right? Put equation number 4. Okay, and this is your p copper. Okay, Cp copper, that is the equation. Number 4. Now the point, if you see, I will derive a relation of copper loss and input power. That this is the power, and in equation 2 we derived Pg equal to omega s into Tt, and we can simplify this one in the form of Pg equal to 2 pi Ns into Tt, right? This is the now the point that we can it is already in equation number 2. If I write here that equation 4 by equation 2, what you will get? P copper by Pg, it is equal to by Tt Ns minus 10 2 pi Ns into Tt. Now let me see 2 pi Tt is cancel. Then what you are getting now? You see here, simplify that P copper P air gap, that is Ns minus Nr by Ns. Then what you are getting? P copper by P air gap, that is equal to slip. Already we got this one. Now you see the relation between copper loss equal to X terms of Pg. That is equation number 5. But you can give the name here. That is, you find out the relation between, okay, P copper loss and air gap, right? Similarly, we can find out another relation of this one. This is very important relation. Now we can find out the relation between PMD, PG, and PMD, PG, and P copper. Now you see, we discussed one point. Keep in mind this formula that P copper loss equal to S into Pg. Okay. Recently we discussed about this equation, that is 4 source. Now the point is, we know that your input power Pg equal to PMD, your output power, plus P copper loss. Okay, this is the general. Means we can write here bracket. We don't know that one, that input is equal to output plus losses in the similar. Now in place of if I put here Pg, you see Pg already we have written here, can write here Pg to Pg, then PMD to PMD, and in place of plus P copper loss equal to S into Pg. Then in this form we can derive PMD equal to Pg into 1 minus, right? This is your equation 5. Okay, equal to Pg rolled into 1 minus S, right? Now you see, suppose I want to find out the copper loss and PMD. Then what we can do? We can see in copper loss PMD going to find out. You see everything I find it out. Now you see when I found. Now you see that I want to find that relation that Pg is becomes 1 by 1 minus S into PMD, right? we can give an equation name this one, that is u 6. Now you see 6 and 4. Compare 6 and 4. What you will get? That P copper equal to S into Pg. Pg is nothing but PMD by 1 minus S. Okay, that is the formula. Then you simplify the copper loss, P copper loss, S by 1 minus S into Pd. Okay, these are the few equations you have to remember. Okay, now you see all the power equations and the relation between them already derived. Then based upon this also we can solve the problems. Now come to the power equations, and from the power equations we have to derive the electrical torque developed, electrical torque developed, as well as the maximum torque. Now you see from the formula you can write here, that is your torque and condition for maximum condition for maximum torque. Okay. Now we'll start from the basic formula, that is your, you see, if I talk about P single phase, what is the power formula? The P single phase, that is nothing but your E into I cos phi, right? And if I talk about the P three phase, 3 E I cos, okay? And if I write E is your EMF induced, then I is your current flow, then cos phi is the phase angle. Now the point what we want to discuss. Now you see that I am talking about the output power. The output power can I write in this form, that P3 phase for induction motor, that is nothing but 3 into ERS, that is ER. ER means rotor EMF at slip S, that IR slip S, and cos phi R slip S. And if this is the power equation, mark it is in equation number 1. Okay. Now one point we have to discuss, ERS, that rotor slip. We already discussed that S into ER0 means, and here ERS is equal to rotor EMF at slip. But ER0, that is your rotor EMF at slip equal to 0. Similarly, we can discuss for other factors. And we know that here the another term, that is your IRS. That already we know that IR is nothing but ERS divided by ZRS, or otherwise we can write here in place of ERS we can write S into ER0 divided by R square plus X S into X R 0 square. neutral, right? Now the point, if this is the condition, then another term, so you can write that cos phi rs, that is equal to nothing but rr by zrs, right? Now you see 3 points we are getting. P3 phase equal to this one, IRS equal to this one, and cos phi equal to this one. Now complete the point next. Now come to the point. Now we'll derive the power. Okay. You see the power formula will put P equal to, we know that 3 into that here we kept that E R S, then into IRS cos phi RS. Alright. Now you simplify, if we will do P into ERS, and IRS is nothing but ERS by ZRS, and cos phi RS is nothing but RR by ZRS. Then can I write here 3 into ERS square into RR divided by ZRS square, right? And in this place, can I write 3 into ERS is nothing but that is your S into ER0 whole square into RR divided by that here RR square plus that S into XR0 square. The root over is cancelled with the square. Okay. Now if we will simplify this equation, the 3 raised power 3 into this square, that ER0 square into RR divided by RR square plus S into XR0 whole square. This is the formula we derived, right? That from the previous discussion, what we got, that your air cap power is equal to omega S into torque developed. That one part we discussed. Another one part also we discussed, that P copper equal to S into Pg. Right? Now you see, leave all the parts. You see, if this is equation 1, this is equation 2, substitute this one, then one we are getting that substitute equation 2, sorry, equation 1, substitute equation 1 into equation 2. What you are getting? That P copper equal to S into Pg. Pg is your omega S into Td. Then copper loss, we develop the power here. Then put this formula here, that is nothing but 3 into S square ER0 square, that is your RR divided by RR whole square plus S into XR0 square, that is equal to S into omega S into Td. But what we required? We required this Td. Then we have to divide this one with these respective equations. Then what to do? The next step, that Td is nothing but 3 into S square, that ER0 square, that RR divided by S into omega S, that is nothing but RR square plus into XR square. Now you see this is cancelled, but 3 is a constant, omega S is also a constant, because you can say omega is is nothing but 2 pi ns, and ns is a constant. Okay, that ns is nothing but capital Ns by 60. And what is the capital Ns formula? Capital Ns formula is equal to 120 Fs by P. And based upon this is also constant, and omega s is a constant. Then we are denoting this Td, then that is a K E R square, sorry, K into S E R square into RR divided by that RR whole square, but S into XR0 whole square. And where you can put here that S by omega S equal to K, or a constant. Okay, this is the fundamental torque equation or torque developed. Okay, now the point we have to discuss, this torque developed, what will happen? Slip is vary. We know that slip will be vary between 0 to 1. When slip is equal to 1, that is your starting condition of induction motor. Then if it is a starting condition of induction motor is equal to 1, then during this condition torque developed is equal to that K into 1 limit here 0 square into RR divided by RR whole square plus S into XR0 whole square. This is the one formula we develop. Now coming to the next, S equal to 0. S equal to 0 means that is your N is equal to NR condition. But we can say at the second condition, this is your condition 1, this is your condition 2, S equal to 0. During this condition, N is equal to NR. Now the point is, if N is equal to NR, what is the torque developed? T equal to 0. And if the torque is developed is 0, then a rotor stops rotating, right? The point is that. Now come to the next. Now come to the point we already discussed about the points. One point is the torque developed equation. Then after that the torque developed equation, we again discuss about the point, that is at starting condition what is the torque. Then the next condition is, we already discussed that when the N is equal to NR, then what is the torque. Then never we got that Td equal to 0 during the Ns and Nr equal to Ns equal to Nr. Then point you have to remember that never and ever this induction motor speed or shutter speed is equal to the rotor speed, because we are getting the torque equal to 0. Similarly, the induction motor stops working. Now come to the next, that is very important point, that is your maximum torque. You can say vertically, see the maximum torque formula. Okay, this is the maximum torque formula we have to develop, that we can say this is the Tm. First we write the formula of the torque, that torque developed, that is equal to 3 into 3 torque developed, which K into S into ER0 square, that is RR divided by RR square plus S into SR0 square. This is the fundamental formula what we know. Right? Now the point, when the maximum torque, we have to understand the point where we can implement this one. Suppose this is the condition of a square plus b square. We know the formula that a square plus b square, that is formula we can write e plus, sorry, the formula we can write a minus b whole square plus 2ab, right? Then can we write in this same form this one? Then what we can write? That is your r minus s into x r 0 whole square plus 2 into r into x into x at 0 formula. Now you see the basic thing what we developed, that we put k into s, that is your er0 square r divided by that r minus s into x at 0 whole square, that is plus 2 into r into x at 0. Now one question I am just asking. Suppose it is k equal to s by v. Then when k will be maximum, then when v is minimum, then k will be maximum, because k is inversely proportional to v. In this condition, this is happening. Now similarly, in this condition also, when the denominator will be decreased, the dt will increase. Means I am just talking about the maximum condition, the dm maximum. How to get? And when your denominator is becomes less, then if I will make this one equal to 0, then here one term will come rr minus s into xr 0 equal to 0. Can I get rr equal to xr, right? Now come to the point. If this is the condition equal to 0, then what we will get? There is two term we will get. You see, this is the term is 0. Then put here in the place of this one, we put this. First we will put in place of xr 0, s into xr 0, rr. Now come to the next slide we will go. That is, but after this one, then we will go to the next slide. Now you see, we already derived this point. Now the point again we will derive, that is, suppose the torque formula we are getting that T maximum. Now I am talking about maximum. Tm equal to that K S R Gs by R, that in this point we'll discuss again that K into S, that is your ER0 square RR. Then we derive to this point that RR minus XR0, that is equal to plus 2 into RR into R0. Now the point you just discussed, this is the thing that this is equal. Okay. That means suppose now let that RR equal to X0, right? Now in place, now you just put in this place the same thing. You will get one value K into S, that ER0 square, that is your S into XR0 divided by 2 into RR S into XR0, right? Yeah. S into XR0. In place of this RR, in place of this RR, put S into XR0. That means it will become K into S square, that ER0 square into XR0 divided by 2 into S square, right? 2 into S square, that XR0 square. Then S square is cancelled out. Then we can say like this will cancel out. What you are getting, that K into ER0 square divided by 2 into XR0. This is one formula you are getting. Similarly, if we put Tm, that is KSER0 square, RR is RR, then 2RR square, then what you are getting? Cancel out that K into S ER0 square by 2 into R. There is the formulas are the maximum torque formula. Here also one maximum torque formula will come. And maximum torque when you will get, when the condition is this one. Then one point is maximum torque formula. One point you can remember that when RR equal to X into XR0, then you will get the maximum torque. Then thank you very much for your patience, and from this we will solve some problems, and next class onwards we will detail analysis only. Okay. First, you see, everyone today will solve some problems related to the power developed and torque related problems. Now you see here in the question, everyone first read the question is 6450 Hz 3-phase induction motor running at full load develops a useful torque of 150 Newton meter at a rotor frequency of 1.5 Hz. Right? The mechanical torque loss in friction, that is 10 Newton meter. Calculate the following: shaft power, the output power of the motor, and the rotor copper loss and efficiency of the motor. Considering the total starter loss means starter copper loss is 700 watt. Now first write down the parameters. In given data, you see here given data, first answer you write. That is your given data. What are they? That pole number is given 6. That frequency, that is Fs, equal to your 50 Hertz given, right? Now 3-phase induction motor. Because we are solving that one. Then come to the torque developed. It is given 150 Newton meter. Then a rotor frequency is given 1.5 Hertz. Then come to the next, that is mechanical torque loss in friction. That is mechanical torque means that is friction loss is given 10 Newton meter. And calculate the following. Calculating the following shaft power, in bracket I am writing P shaft. Okay. Second one I am writing, that is the output power of the motor, that is nothing but the mechanical developed power. Third one is the rotor copper loss. Okay, that is the third one. And fourth one is the efficiency, right? But one point you keep in mind that in the question again the another point is given, that is starter loss. Starter loss means we can say P copper, that is how much? 700 watt. Okay. Now before going to start, we write some formula. That is formula what we know. That one we know that air gap power is nothing but that Pg, you can say that omega s into Td, and Pg is nothing but it is input power. Similarly, mechanical power also we know that is nothing but omega into Td, right? And another one which you also know that P copper loss, it is nothing but that is your Td to omega s minus omega. These are the few points we discussed. Already you know. Now come to the relation between this, that we know that P copper loss, P copper of the rotor, that is equal to S into PG. Similarly, P copper with respect to the output, that is S1 minus S into P mechanical power. Another point also we can write, that is the thing, that is that is relation between the input as well as the mechanical power, that nothing but we can say that uh, just write down here that P copper is equal, that means SPG equal to S into 1 minus S into PMD, right? That means if you SS each cancel, then one relation will come, that PG is equal to 1 by 1 minus S into PMD, right? This is one of the formula what we derived, and this is the one of the formula, and okay, the other formula. These for based upon this formula only we can derive all this problem, or we can solve this problem. Otherwise it is difficult. Right? First we see shaft power. Then we go slowly back to the formula first. One. Now the point we have to discuss, that first point, first we just write here. It is one point, that is nothing but shaft power. Shaft power is nothing but the useful output power, and the formula will become, that is omega r into Tt. But you see, in this question, the omega r into T, Tt value is given. Tt value is how much it is given in the question? That is your 150 Newton meter. But the omega r value is not given. Then omega r, what we know, the formula of omega r, you can write it, that omega r equal to 2 pi nr. 2 pi nr also not. Then what is the formula of NR? NR is nothing but capital NR by 60, because small nr is represented in RPS, revolution per second, but we have to make it, because NR is in RPM by 60. But how to find out this NR? Because we know the slip formula, slip equal to Ns minus Nr by Ns. Now you see, in this formula also we can find out the Nr, but we should know about the synchronous speed as well as we should know about the slip. Then only this factor only we can compute. But how to compute this factor? You see, this is the point I want to explain. Now first you see, we need the synchronous speed, that is ns. Okay, then ns, how to complete that? Ns we know, don't you know about ns, that is capital Ns equal to 120 fs by p, that we know. But 120 into fs value, fs is how much? 50 hertz, it is already united, that 50 by P. P is how much? 6. If I will calculate this one, it will come around 1000 RPM. Understand my point? If this is 1000 of RPM, but I need small ns. How to calculate this small ns? Small ns nothing but capital Ns by 60. That is your 1000 by 60. Around it will come that almost, if I will calculate like this, then the NS value will come like 1000 by 60. You can calculate like this only. Okay. Now the point again, you just see. Otherwise, in this format also NS you can calculate. Otherwise, you can put here directly NS equal to 1000 RPM, and but the point is NS you calculated. Okay. Now come to the slip. Slip, how to calculate slip? Sleep is equal to, there is a formula. This is the one of the formula. And see what are the parameters given in the question. In the parameter given, the starter frequency is given and the rotor frequency is given. Then can I write the formula related to that? Starter frequency equal to the, sorry, that is your rotor frequency equal to S into shutter frequency. Then rotor frequency, how much it is given? Rotor frequency is given 1.5 hertz equal to sleep. Sleep into Fs. Fs is how much given? 50 hertz it is given. Then you can easily calculate sleep equal to 1.5 by 50. Then how much it will come? Almost it will come 0.03. And you see this 0.03, if you will see the practical sleep condition, that is lies in between 0 uh, sleep and 1. Sleep is lies in between 0 to 1. That means this sleep is a right value we are calculated. Now you see by using the sleep as well as the speed ns, then you can easily calculate the how to calculate the nr. You see the next slide. Now you see two factors we calculated. One is your sleep. You see, sleep is how much? Sleep is equal to 0.03 and NS is equal to 1000 RPM. And what is the formula? We know that sleep equal to NS minus NR divided by NS. Then you see NS value we calculated 1000. That means in this formula if we will solve, then can I say that SNS minus NS equal to minus NR. Then in this form I represent NR equal to NS. Take common 1 minus S. Now you see NR value how to calculate. NR is nothing but NR value how to calculate. NS value is how much? You can write here NR equal to 1000 1 minus 0.03. The value will come around 970 RPM. Okay, then are equal to 970 RPM. But what we need, that is your omega R. Omega R is 2 pi small nr. Then in this form, the small nr is required. Then small nr, how to calculate? Then we know that small nr is nothing but nr by 60. That is your 970 RPM by 60. Then the value will come approximately, the value will come, one second, that is mm, just keep as it and you multiply here, that is your 2 pi, that is into 970 by 60. It will come around 101.578 radian per second, right? But what is the formula of shaft power? What is the first question? The shaft power. Shaft power is how to calculate shaft power. Shaft power is omega R into TD because useful power. How much omega R? Omega R is 101.578 into 150. That is the value will come 15236. Okay, point something watt, right? This is the value we are calculating the shaft power. Similarly, now next point we have to calculate the mechanical power developed. That how to calculate the mechanical power developed? That you see here the mechanical power developed formula, that is your PMD, that is nothing but omega R plus the torque. And here the torque is there, two types of torque is there. One is useful torque, another one is your uh, friction torque. That is means total torque is this one. Then omega R, what we calculated, that is 101.578, right? That is what into TD. TD is how much? That is 150 Newton meter plus TF is 10. The total value will come like this. That is your 16252.48 watt. That is the mechanical power. Okay. And if we are getting the mechanical power PMD is this much, then we already know the formula how to find out the peak copper loss across the rotor. That is the formula is S by 1 minus S into PMD. S is how much? That is 0.03 by 1.1 minus 0.03. That is P mechanical. That is what 16252.48. Right? If we will multiply this one, we will get that 0.5026 kilo. Okay. You can write like this kilowatt, otherwise you can write 502.6 watt, right? This is peak of performance. But what is you required last? This is your second point you calculated, third point you calculated, then fourth one, that is your efficiency. Efficiency what? Output power, that is P shaft by P input. P input. Input how to calculate? We know that P input is nothing but that is your mechanical power developed plus P copper across the rotor, then P copper across the starter. Then P mechanical, how much? P mechanical power it is derived 16252.48 plus P copper loss road plus this was 502.6 watt, right? And plus P copper in starter, that is just 700 watt. Then total value will come around, that is 174546 watt around to come. But if it is the input power you are getting, in P shaft power, how much you are getting? That efficiency now you can calculate P shaft 15236 what you calculated divided by 174546 into 100. Okay, that is your 100 means 87.29%. Okay, this is all about the points we have to understand. Okay, now it is the final answer for this question. Similarly, if further questions will come regarding this, you have to solve like this. Now my point is, now we solved a problem to previous discussion. Now today onwards, so what we will do, we'll start another discussion, that is the relation between the torques, because power relation we already discussed. Now the torque relation we will discuss. First you write the torque formula. TD, you know that is your K into S ER0 square into RR divided by, that is your RR whole square plus S into XR0 whole square. That is the torque formula, means that is your, we can say, full load torque. We can give a name of this one, this lecture, in this that relation between different torque. Okay, the relation between different torque, and this is what I told. This is your full load torque. Okay, and full load torque we can write TD, right? Another torque will come, that is your maximum torque. The maximum torque formula we can denote TDM maximum. That is nothing but that K E R0 square divided by 2 into XRG. Right? This is the maximum torque condition. And this is the condition will happen at what condition? That is nothing but when your rotor resistance equal to slip, maximum slip into starter resistance, which is rotor reactance. This is the condition. In this condition, that full load torque means we can say that in this condition, this is the formula. Now last one, that is your starting torque. Starting torque. Now the point is starting torque. The formula is TD starting you see put starting torque means is equal to 1, because you see in starting condition the rotor speed is equal to 0. That means slip equal to ns minus nr by ns. Rotor speed is 0 means slip equal to 1. That only I am putting here. Then put in this equation slip equal to 1. The formula will become k er0 square r divided by r whole square plus xr0 whole square, right? This is the starting. Now you see how to find out the relation between themselves. What we can do, we have to connect all these things. Now you see there is one point. First you see torque developed, okay, at full load divided by torque developed at maximum condition. Input the formula here, that is K is ER0 square into RR divided by RR whole square plus S into XR0 whole square. Now divided by this one, torque developed at maximum condition, what it will come? That K ER0 square divided by 2 into XR0. Now, because I am finding out the relation between these two, then what I will derive? Then you see in this form, if I will use different thing, that k means k cancel out, er0 square, er0 square cancel out. Then what I am getting, that is rr divided by srr divided into srr into that 2 into xr0 divided by that rr whole square plus s into xr0 whole square. Right? Now in this form, what is the maximum torque condition? Maximum torque at what condition? We know that rr is equal to sm into xr0. In this form, suppose we'll put now rr into in this form, what I will get? That you see in this form, if I will write in place of rr, I am putting this one, then what I will get? That TDFL full load divided by TD maximum condition, that S into, okay, SM into XR0, S into SM into XR0, that into 2 into XR0. Then what I am getting? Divided by that is X, sorry, Sm into xr0 whole square plus s square xr0 whole square. That means this will come like this. If you will put here 2 into s into sm, that xr0 whole square divided by here xr0 whole square, take common, that is your nothing but sm square plus s square. Now, if you will simplify this equation, then this equation will become TD full load divided by TD maximum condition, that is equal to, you see, XR0 and XR0 is cancelled out, square, then the formula will become 2 into S into SM divided by SM square plus square. Okay, this is all about this formula. Now coming to the next point, that is will come, suppose full load by maximum I have prepared. No, I got this one. Suppose I will change to starting by the maximum. In starting, what is the formula for starting torque? That is TD starting. The formula is K S is equal to 1. That means ER0 square into R, right? Divided by here RR whole square plus XR0 whole square. That is the starting term. And if I will divide by the form, that is your TD maximum. Then TD maximum, what we will get? That KER0 square divided by here RR whole square. Sorry, this is not there. We just KER0 KER0 square, that is into 2 into XRG, right? Then you just cancel out these two. KER0 square, KER0 square is cancelled. Then the form will come like this. That is nothing but RR divided by RR into 2 into XR0. That is nothing but RR square plus XR0 square. Now you see, in place of this RR, we have to keep that SM into XR0. Thus, this is the maximum slip and my reactance. Then in this form, if we will keep, that is nothing but SM into XR0, that is nothing but 2 into XR0 divided by, that is SM XR0 whole square plus XR0 square. Now, if you will multiply, the equation will become 2 into Sm, that is XR0 whole square divided by Sm square plus 1, that is nothing but XR0 square. Now, XR0 square, XR0 is cancelled out. The final formula we can write that TDST by TD maximum, that is equal to 2 into Sm divided by Sm square plus, this is the formula. Similarly, what is Sm? Sm is nothing but that is your maximum slip. Maximum slip condition. Right. Now to the next. Last condition. We will derive one. That is, suppose we will derive the full load torque like TD full load divided by TD starting condition. TD full load, what is the formula? That is KSER0 square RR divided by RR square plus S into XR0 divided by starting, that is KER0 square RR divided by RR square plus SR0 square. Right? Now you see what are the parameters cancelled out. KK cancelled. Then ER0 square, ER0 square cancelled. RR is cancelled. Right? Now what will come? Like the RR square plus XR0 whole square divided by that RR square plus S into XR. Now in place of R, you just put SM into XR0. Then it will put like this, but it will come SM square XR0 square plus XR0 whole square divided by, that is SM square plus S square XR0. Now can take XR0 whole square. Now can take the common. Here, I think SM square XR0. Now what you can do, then you take common XR0 whole square equal into Sm square plus 1 divided by here XR0 whole square, that is your Sm square plus S square. Then these two will cancel out. Then what you can get, that TD FL by TD ST equal to that Sm square plus 1 divided by Sm square plus square, right? This is the formula for computing this relation. You see the relations we derived three conditions. One is full load torque, another one is your starting torque, another one is the maximum torque. And by using the maximum torque relation, we derived the relation between all the torques, and these are the formula. based upon this numerical problems we can also solve. These are the basics. But we discussed about the torque in electrical torque. Now we solve the relation between them. Okay, everybody can analyze these things and try to solve some problems.